Okay, the books do not cover this. Very few books cover this topic. The point of going through what's happening with memory is to make sure you understand how Java is creating your objects, how they're being used, and why you have certain errors at certain points. So this is a very special topic because it's generally not covered. It's just implied in the way the books talk about it, but I want to be explicit on how everything's actually interacting. So here I'm going to talk about different types of memory, static, stack, and heap, and I'm going to talk about a pointer and what that actually is. And Java is nice because it's actually going to do a lot of the work, memory work for you. C++, you never did new in C++, did you? No, which is good because that's a whole can of worms, I should say, in C++. In Java, it's going to simplify this process for you. Okay. There are 3 categories of memory on your computer, general categories, let me put it that way. You have your static section, which holds anything known prior to runtime, and its lifetime is the entire execution of the program. So everything in static is static. And let's see, the lifetime is the entire program execution. So what would be in there? What is known prior to runtime? And do you know what I mean by runtime? You compile your program, produces the binary or the bytecode, and then runtime is when you go to execute it. What would be known at that time?
Any variables in the program?
Okay, certain variables in the program.
The given ones?
The global ones. Is that what you said? Given? Global variables would be known. Now, your certain variables may be allocated or deallocated, but your global variables will exist throughout the whole program. What also exists throughout your whole program?
Your functions?
Your functions. Your code. Right. Your code always exists in memory. And for the sake of argument, let's say it does not change. If you try and write a program that modifies itself, bad things will happen. Don't do that. But for the sake of argument, your code is static. It does not change. It's stored in memory. It's stored in static memory. Okay, runtime stack, memory associated with active functions. So I call them stack frames here, or active records. This is something that happens with functions. We'll go into a little bit more in a bit. And then your heap is your dynamically allocated storage, and where you're just dynamically allocating it when you need it. And we'll go into that in a little more detail soon. So static, simplest type, consists of anything, compile time, global variables, constants in your code. Storage requirements is known prior to execution. It's very important because you know how long your program is, so you know how much memory your code is going to take up. You know what your global variables are and what their types are, so you know how much memory those are going to take up. So everything has to be known before execution. All right, runtime stack. Think back to C++ when you created functions. If you had a function, a variable inside the function, what was the lifetime of that variable? Let's see. You see that? Right. Void. Let's call it function 1. And then you have int a. Dot, 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 dot. How long can you access a?
As long as you're in that function.
As long as you're in that function. Once you exit that function, what happens to a? Can you access it still?
No.
Well, after your function returns, that piece of memory is deallocated. So we have function 1. And let's go down to void function 2. And we'll say function 2 calls function 1, and maybe it has int b. Dot, dot, dot. All right. Let me show you exactly what's happening here. When you're thinking of memory, just think of it as one giant array. you'll have your static up here. It is fixed, so you know exactly where it is. And we'll just say your code, your global variables are right here. First thing that happens is your stack comes in right afterwards. And if we were in this piece of code, let's see, can you see down here? Great. Int main, I'm using just some shorthand, and you call function 2. The first thing that happens on your stack is it allocates the memory for main. Main. Main doesn't have any variables, so we're just going to say it takes up that piece of memory. Once execution goes here, you see that? Great. Where does it jump to? Function 2. So it's up here. Function 2 has a variable called int b. So it has int b right here. It allocates what's needed for function 2 and the variable int b. When execution goes to function 1, what happens? By the way, let me update the stack pointer. It goes where?
Function 1.
It goes up to function 1. So it needs to allocate function 1. So function 1 is allocated and it has int a. Stack pointer goes to here. What happens on the return? It jumps back to function 2. Okay? When it jumps back to function 2, the stack pointer jumps back to the end of function 2, which means that you no longer have access to integer a, because the stack, you can always go from the beginning, because it's going to have essentially a begin pointer, and to the end of the stack. Once you come back from function 1, that is deallocated. You don't know where, you can't have access to it anymore. To really drive this example home, let me go ahead, we have function 1. Let me go ahead and create a function 3. Let's see how much space I have. Okay, good. So I'll just create it right here. Sorry for the terrible drawings. We'll call it a double D. So now, we're going to jump from function 1 to function 3, which means it's up here. Everyone tracking? Any confusion? I just added function 3 to the function 2. All right. Which means the stack is now going to allocate memory. Notice it's overriding the old function, where that was. Function 1 code, or memory I should say, with function 3, double D. And we'll just say it takes up a little more memory. Then your stack pointer goes to here. So that whole int a from function 1 has been overwritten with what function 3 was. Okay? When you return from function 3, you're back to function 2. That just updates the stack pointer to the end of function 2. So now we're down here. Now we're going to return from function 2. So the stack pointer is going to then be pushed up here. And then finally we're going to return from main, and that actually signals the end of the program, and we're done. Any questions about that? That might be kind of tricky at first. No questions? Okay. But do you see how the lifetime is associated with how long it's within that stack range? So keep that in mind. Also, what's one nice thing about the stack? That might be hard to see right now. But one thing to keep in mind about the stack is that it's contiguous. It's going to grow and shrink as you call functions. It's not going to have holes. It's going to always grow and shrink depending on how much memory you need. Okay, it grows, storage is allocated when you need it. It shrinks when a method terminates, aka it's deallocating. So here's an example from the slides. I went through this on the board. So if you want to review this, go ahead. But I think we did it pretty well back there. there's another video if a lot of this doesn't make sense. All right, this is the key thing. The stack keeps track of your local variables, parameters, and your return linkage. So anything local, all your local variables to your function are stored on the stack. What local variable have we talked about that would not be included in the stack? What's new? Well, what's new in Java? So let's get to that in a minute. So heaps are allocated and deallocated dynamically as the program runs. It's not fixed to a function. The heap in this picture starts down here and grows up. The stack, of course, grows down. Now, it may be switched in certain pictures, but they're always at the opposite ends of memory.
So the heap is like the final answer? Like what it stores is the final answer?
So the heap is just another way to access memory or allocate memory. So notice that your local variables like int A, int B, double D inside the functions were allocated on the stack. I'm just telling you there's another piece of memory called the heap that starts at the other end. But it's going to work differently. It's not going to work via a stack. Whenever you do a new in Java, you don't have to worry about free and delete because we're in Java. You're going to allocate something on the heap storage. Okay? So let's go back to our example we drew. Let's say, for the sake of argument, inside of function 1, we have that bank account. Count BA equals new bank account. All right, so that 2, can you see, do you understand what I'm typing there? All right. So let's go and run this program again. So we start in main, we allocate main. So execution goes here. Main's been allocated, we're going to call function 2, which is right here. So we'll say we're right here, function 2. Initialize, let's see, we got function 2. We have integer b, and the ending stack pointer is right here. All right, we're going to call function 1. So we're up here. Well, what's happening in function 1? We have int a, and we have bank account BA. All right, here's where it gets tricky. The stack goes to here. New bank account means we're allocating a bank account object. Objects are always allocated on the heap in Java. So we're creating a bank account down here. And I think we had, we'll just say that the M amount is equal to 1,000, like in our code. And then, what was the other one? Account number. Equals 1, 2, 3, 4. What's happening is that new bank account allocates the memory here. We'll say heap is between these two objects. And then it's copying a pointer to BA, which means BA points to right here. Okay? All right. Now, we return out of function 1. So the stack pointer goes up here. Nothing actually changes. We stay like that. We go back to function 2. We jump down to function 3. So function 3 is going to be allocated, and we're going to be up here. So now function 3 You have double D, and we'll say it ends right here, and this pointer no longer exists. And the stack is right there. All right. Does the bank account still exist? Yes, the bank account still exists. It is persistent until it's deallocated. So function 3 continues. It ends. So the stack pointer's going to jump up here. And then we're going to exit function 2. So the stack pointer goes down to the end of main. And then we end. Notice that that bank account still persists. So the heap is a way to have persistent memory or data throughout your entire program. Not something that's based on calling or the allocation, deallocation of a function. All right. Any questions about this? This can be a jump. No questions? Wow. What happens? Whoa, shaky camera. What happens if the stack keeps growing and then the heap keeps growing and they meet? Okay, stack overflow, but more specifically, what has happened? You have run out of memory. So if you keep allocating, eventually you will run out of memory. All right. So heap management. What's another problem with this example? Well, I will answer my question. This down here sticks around, but maybe it's not needed anymore. So we need to deallocate this memory at some point. If you were doing C++, you'd have to do that manually. Java does it automatically for you. Once it detects that there's no more pointers pointing to this object, it'll mark it for deletion later on at some point. So Java's going to deallocate the heap for you, and that just happens at some point. Other languages, you have to do it automatically, like C++. I mean, you have to do it, manually. Here's another picture of static, stack, and heap. Notice the code, your function calls, your dynamic memory coming up from the heap. Stack overflow, or memory out of memory, happens when the stack and the heap meet. Okay. And I don't think we need to talk about the rest of this. Okay. Any questions on this? It's important to keep this in the back of your mind so you understand what's happening when you allocate objects. All right. I've assigned a lab, so you definitely have plenty of work to do. I'm going to email you the reading soon for next class. And if you have not already emailed me your project ideas, please do that soon. I'm going to start collecting what people want to do for their projects. So please email me that ASAP. I'm going to send an email out asking people to tell me their top 3 project ideas. All right. Any other questions? Okay, great. And then have time to work on your lab and have a good weekend.